Today we're going to look at CompTIA Security's Guide to Network Security Fundamentals 6 editions, Chapter 6 of Network Security Devices, Design and Technology. The objectives of this chapter is to list the different types of network security devices and how they can be used. We're also going to look at describing security network architecture and also explain how network technologies can enhance security. And security can be achieved through the standard security features found in standard networking devices, as well as hardware design that's going to be designed primarily for security. So looking at some standard network devices, these will be classified by the OSI layer which they function. The OSI layer is going to have 7 layers, and it breaks networking down into steps. So each layer is going to have a different networking task, and each layer is going to cooperate with its adjacent layer. The security functions of a network device can be provided a degree of network security, but if it's improperly configured, a standard network device can introduce vulnerabilities. Some of the devices that we're going to look at include bridges, switches, routers, load balancers, and proxies. All right, bridges are hardware devices or software that's used to join 2 separate computer networks to enable communications between them. So they can be used to connect 2 local area networks or 2 network segments. They do operate at the data link layer, which is layer 2 of the OSI, so that all network segments connected must use the same layer 2 protocols. Now, most OSs do allow a software bridge to connect 2 network segments, but creating a software bridge could create a security vulnerability. So we see the example here of a Microsoft Windows software network bridge being created. All right, switches, they're a device that connects network hosts intelligently. What they could do is they can learn which device is connected to each of its ports. Now they examine the MAC address of frames that it receives, and it's going to associate its ports with the MAC address of the device connected to that port. It's then going to store that address in a MAC address table. So they'll then forward the frames intended to a specific device, which is a unicast, instead of sending it out to all the ports. It is important, though, for switches to be properly configured to provide a high degree of security. Now, some proper configuration will include loop prevention and providing a flood guard. See an example of a broadcast storm. Now, a flood guard, what this does is it's a defense against a MAC flooding attack. So what a MAC flooding attack is where a threat agent may attempt this by overflowing the switch with Ethernet frames that have been spoofed, so that each frame is going to contain a different source MAC address. The flood guard is also port security. So if the switch supports port security, it can then be configured to limit the number of MAC addresses that can be learned on the ports. And they will protect against the MAC flooding attack. Routers, they're going to forward packets across different computer networks. They're going to operate at the network layer, which is the layer 3 of the OSI. They can be set to filter out specific type of network traffic using an access control list. You can also set them to, they can be used to limit traffic entering the network from unapproved networks. Now, a load balancer, they help to evenly distribute work across the network, and they allocate requests among multiple devices. Some advantages of load balancing technologies: it reduces the probability of overloading a single server, and it optimizes the bandwidth of the network computers. Now, this can be achieved through software or hardware devices, and they're going to be grouped into 2 categories. You have your layer 4 load balancers that they act upon data found in the network and transport layer protocols. And you have the layer 7 load balancers, which they're going to distribute requests based on the data found in the application layer protocols. There are some scheduling protocols used for load balancers. You have round robin, affinity, and others. All right, Proxies, there's got several different types of proxies used in computer networking. You have a forward proxy, which is a computer application program that intercepts user requests from the internal network and processes that request on behalf of the user. You have application or multi-purpose proxies. That's a special proxy server that knows the application protocols it supports. A reverse proxy routes requests coming from an external network to the correct internal server. And a transparent proxy, this does not really require any configuration on the user's computer. So some examples here of a forward and reverse proxies. So the forward proxy is sending the information on with its own IP address. Notice it's not the source IP address. Goes to reverse proxy. From here it's saying, okay, I need to make sure I go to the web server 1 to get the information, and it's reversing the information and sending it back. The advantage of proxy servers, it does increase speed, it reduces the cost, it has improved management, and stronger security. Now, network security hardware, this is devices that are going to be specifically designed for security. These are going to provide greater protection than your standard networking devices. And some of this software or some of this hardware will be things like firewalls. Now, firewalls can be software-based or hardware. Both are going to do the same thing. They're both going to inspect the packets and either accept or deny entry into the network. A couple of differences: the hardware firewalls tend to be more expensive, and they're more different to configure and manage. Software firewalls running on a device, they provide protection to that device only. They don't provide protection to the entire network, just that computer. So pretty much all of your modern operating systems now include a software firewall, and it's going to be called a host-based firewall. See an example here of a hardware-based firewall. This is an enterprise hardware firewall. This is an example of a software-based firewall. This is your PC, your Windows firewall. Notice that some of these things are said here, like the incoming connections. It's block all connections to apps that are not on the list of allowed apps. And so you can tell what to add and what to not to accept traffic from. So we see an example of a network firewall. The traffic comes in through the router. It's routed. It goes to the firewall. The firewall is going to decide whether or not the traffic is allowed through or not based on the rules. We do have some methods of firewall packet filtering. Stateless packet filtering that inspects incoming packets and either permits or denies based on conditions set by the administrator. Stateful packet filtering that keeps a record of the state of the connection, and it makes decisions based on the connection and conditions. Now, with the firewalls, it's got a couple actions it can perform. So when it gets a packet, it can either perform to allow the packet to pass through. It can drop the packet, which prevents a packet from passing to the network, and it sends no response back to the sender. Or it can reject the packet. That still prevents the packet from passing to the network, but it's going to send a message back to the sender and let them know that it was not reachable. A rules-based firewalls, these are set up individual instructions to control actions. Each rule is a separate instruction processed in sequence telling the firewall what actions to take. The rules are going to be stored together in one or more text files, and they're going to be read when the firewall starts. And these are going to be static in nature, so they can't do anything other than what they've been configured to do. You also have application-aware firewalls. These operate at a higher level by identifying applications that send packets through the firewall and make decisions about what actions to take. The application can be identified by the application firewall-based firewalls through predefined application signatures, header inspection, or payload analysis. Web application firewalls, these are a special type of application-aware firewalls. They're going to look deeply into packets that carry HTTP traffic, and they can be used to block specific sites or specific types of HTTP traffic. A virtual private network, what this does, it enables authorized users to use an unsecured public network like it was a secured public network or private network. All data is going to be transmitted between remote devices, and the network is encrypted. We've got a couple of types of VPNs. You have user to LAN connection, which is the remote access VPN. You've got site to site, which is multiple sites can connect to other sites over the internet. Always on VPN allows the users to always stay connected. One of the terms you'll hear for VPNs is endpoints. That's the end of the tunnel between the VPN devices. And those could be either software, it's on a local computer, or a VPN concentrator, which is a dedicated hardware device that aggregates hundreds of thousands of VPN connections. Now, we do have a couple options here when you use a VPN. You can have it where all traffic is set to the VPN and protected and called a full tunnel, or only some traffic is going to be routed over a secure VPN. And when that happens, all the other traffic directly accesses the internet. This is called split tunneling. All right, your mail gateway, you got two different email systems you use. One system is going to use the TCP/IP protocols to send and receive messages. This is going to use your SMTP, your Simple Mail Transfer Protocol, or your Post Office protocol, the POP or POP3. You also have the IMAP, the Internet Mail Access Protocol. This is something that's more recent and advanced email system. What this does, the email remains on the email server and is not downloaded to a user's computer. Now, a mail gateway, what this does, it monitors email for unwanted content and prevents these messages from being delivered. So like for inbound emails, it can search for various types of malware, spam, phishing attacks. For mail going out, it's going to detect and block the transmission of sensitive data. The network intrusion detection and prevention. An intrusion detection device is called an IDS. It can detect attacks as it occurs. A couple of times you have these inline IDS that connects directly to the network, and it's going to monitor the flow of the data as it occurs. Or you can have a passive IDS, which is going to connect to a port on a switch, and it's going to receive a copy of the network traffic. Now, these can be managed two different ways. You have inbound that's through the network itself by using network protocols and tools, or you can have it where it's set to out of band, which is using an independent dedicated channel to reach the devices. So we see the difference between inline and passive IDSs, intrusion detection and prevention systems. All right, so we see inline, the connection of it is directly to the network, while passive is connected to a port on the switch. The traffic flow is routed through the device on the inline. It can block attacks. The detection error, though, may disrupt services. Where on passive, it just receives a copy of the traffic. It cannot block an attack, and it may cause a false alarm. Now, we do have some different types of monitoring methodologies we can look at. We have anomaly-based monitoring, which compares the current dedicated behavior with baseline, or current detected behavior with the baseline. You also have signature-based monitoring, which that looks for well-known attack signature patterns. The behavior-based monitoring, it detects abnormal actions and processes and programs. And then it alerts the user who decides whether to allow or block the activity. The heuristic monitoring, it uses experiences-based techniques. Now we got two basic types of IDSs exist. You have your host intrusion detection system. It's a software-based application that can detect attack as it occurs. This is installed on each system that needs protecting. Some things it does monitor system calls and file system access. It can recognize unauthorized registry modifications, host input and output communications, and it detects anomalous activity. Now, the disadvantage of this is it cannot monitor network traffic, does not reach the local system. All log data is going to be stored locally, and it is resource intensive and can slow the system down. You also have the network intrusion detection system. What this does, it watches for attacks on the network. This is something that's going to be, the sensors are going to be installed on firewalls and routers. So what it does, it gathers information, reports it back to a central device. It can sound alarms, log events. You have application aware IDS. It's a specialized IDS. It uses contextual knowledge in real time. It can know the version of the operating system which the application is running, or which application is running. So it knows what vulnerabilities are present in the system being protected. Now, an intrusion prevention system, this monitors network traffic to immediately block a malicious attack. It's similar to the NIDS. This is located inline on the firewall, and it allows the NIPS to more quickly take action and block an attack. Once again, you have application aware IPSs that know which applications are running, as well as the underlying operating system. All right, security and information event management product. It consolidates real-time monitoring and management of security information. It analyzes and reports on security events. Now, these can be a separate device. It can be software that runs on the computer, or it could be a service provided by a third party. So we see an example of a dashboard here. Looking at this, you just see a bunch of charts. But it gives you a lot of information once you get into the event management. All right, so these are some of the following features that it does have. Typically, we do have some other network security hardware devices. We're not going to go through all of these. We have the descriptions, the name of it, the description, and the comments on the devices. Now, you can also achieve security through the design of the network. It can provide the secure foundation for resisting the attackers. Some of these are creating security zones or using network segregation. So we look at security zones, a secure approach to create a zone to partition the network. Now, what this does, it allows users to enter one zone while access is prohibited to other users. The most common security zones are demilitarized zone, or using network address translation to create zones. So we'll look at the DMZ. That's a separate network. It's located outside the secure network perimeter. For example, in this diagram here, untrusted outside users can access the DMZ, but not the secure network. So we're building it where they can go in here, but they're not allowed into this area. This is a secure network here. Now, what the network address translation does, it allows private IP addresses to be used on the public internet, but it replaces that private IP address with a public address. So the advantage of this, it masks the IP address for internal devices. So the attacker that may grab that packet over the internet, they can't determine where the actual IP address of the sender is. So we see an example here. We've got the IP address 192.168.0.3. That's the IP address of this user. So he's going to send out a request or an email. So his sender IP is sent. The packet is going to create it on the computer with a private IP over here. It goes into the NAT. The NAT's going to take that original IP address and it's going to replace it with a public IP address. So the public IP address is 192.146.118.20. That is going to be sent with the packet across, in this case, the internet or an email address. So it's taken it keeps this private email address private, or replaced it with a public email. A public IP address. Now we can also have other zones. Intranet, it's a private network that belongs to an organization, can only be accessed by approved internal users. Security benefits of this is it's closed to the outside public. So that data is going to be less vulnerable to external threat actors. We also have an extranet. That's a private network that can be accessed by authorized external customers, vendors, and partners. The benefits of this is it can provide enhanced security for outside users compared to a publicly accessible website. We also set up a guest network. It's a separate open network that anyone can authorize without prior authorization. Now, this does things like permits access to general network resources like web surfing without using the secure network. We also have network segregation. So what we do is we isolate the network so it's not accessible to physical network segregation. It's not going to be accessible by outsiders. We have an air gap. That's the absence of any type of connection between devices. In this case, it's going to be between the secure network and another network. Now, these networks can be segmented by using switches to divide the network into a hierarchy. Core switches are going to reside at the top of the hierarchy and carry traffic between switches, while work group switches are connected directly to the devices on the network. You can set up a virtual LAN that allows scattered users to be logically grouped together. And it can be attached to different switches. They don't have to be all attached to the same thing. Now, what you can do then is you can isolate sensitive data to the VLAN members. You can add communications on the VLAN. So if someone is connected to the same switch, the switch is going to handle the packet transfers. And then you can have a special tagging protocol that's going to be used for communicating between the switches. You can also secure through network technologies. We have two technologies that we can use to secure a network that can help secure a network. You got network access control and data loss prevention. All right, network access control. What this does is it examines the current state of a system or network device before it can connect to that network. So any device that does not meet a specific set of criteria cannot, they're only going to be able to connect only to a quarantine network where any security deficiencies are going to be corrected. The goal of this is to prevent computers with suboptimal security from potentially infecting other computers on the network. It's going to use software agents to gather information and report back to the host agent health checks. An agent may be a permanent NAC agent or a dissolvable NC agent, which disappears after reporting information to the NAC. NAC technology can be embedded within a Microsoft Windows Active Directory domain controller. And what it is going to use the AD to scan the device. This is called an agentless NAC. So we'll see an example of this. So what we got here, we have the number one is the security self-assessment by system health agent. All right, so if we don't have any health certificate here, it's going to be sent to quarantine. It's only going to be able to connect to that network until it's fixed. If we have it, the statement of health is going to be sent to the Health Registration Authority. All right, so it checks, everything works out, it sends the health certificate to the client, and then it's going to allow it to connect to the network server. If this doesn't pan out, if this doesn't get sent back and it doesn't pass, it's going to this quarantine. All right, data loss prevention. DLP is a system of security tools that's used to recognize and identify data that is critical to the organization, and it ensures that it is protected. We got two common uses of DLP. You got monitoring emails through a mail gateway, or you got blocking and copying of files to a USB flash drive. This is called USB blocking. Most DLP systems use content inspection. Okay, that's defined as a security analysis of transaction within its proved context. Content inspection is not only the security level of data, it's not only looks at that, but it's also looking at who is requesting it, where the data is stored, when it was requested, and where is it going. We've got three types of DLP sensors. You have your network sensors, your DLP storage sensors, and DLP agent sensors. So when a policy violation is detected by a DLP agent, it's going to be reported back to the DLP server, and you have different actions that can be taken. It can block the data. It can redirect it to an individual who can examine the request. It can quarantine the data until later, and it can also alert a supervisor of the request. So when we're looking at how to secure the network through technologies and devices, remember we do have standard network security devices. They do provide some type of degree of security. We do have hardware devices that are designed specifically for security, and they're going to give you a higher level of protection, such as the firewall or web application firewall. Virtual private networks, they use an unsecured public network and encrypt it to provide security. Mail gateways monitor emails for unwanted content and prevent these messages from being delivered. Intrusion detection systems, they're designed to detect an attack as it occurs. Security and information event management product that consolidates real-time monitoring and management of security information, along with an analysis and reporting of security events. You got other network security hardware devices that include hardware security modules, SSL decryptors, SSL/TLS accelerators, media gateways, UTM products, internet content filters, and web security gateways. Some methods for designing a secure network include demilitarized zones, virtual LANs, and once again, you can use network technology to help secure a network, such as the network access control.